Hello, my dear friends. Today I will be discussing some major organic concepts under alkanes, and after we've discussed the major conversion methods under alkanes, mainly the theory parts, then we'll be doing some questions or conversions under alkanes and various ways that can be which a conversion can be performed quite easily. So first of all, let's memorize or revise the map, or kind of a map like structure where we can comprehend all the conversion methods under alkanes. So without any further delay, we'll get on with the concepts. Alkanes. We represent alkanes by CnH2n plus 2. Afterwards, alkane is a structure like this: CH3, CH2 and CH3, and these alkanes are already saturated. We have no bonds could be broken. So let's directly get into the conversions. First of all, I'll add numbers for each conversion process that we'll be performing. At the beginning, we'll be revising that this reactants that give the following product after the conversion. So CH3, if an alkene of any kind, for example CH3, CH2, or else if it's an alkyne, even this same result could be obtained. That would be CH. For both of these alkenes and alkynes, if we add hydrogen, nickel, platinum or palladium, whatever it is, you don't need to add all of these stuffs, but just hydrogen with something else like nickel is just sufficient. Once heated, will give you an alkane. So there are three specific methods where you can obtain an alkane by adding certain regions to specific organic compounds. So if you add hydrogen, nickel, palladium or platinum either for an alkyne or an alkene, you will get an alkane as the end product. Afterwards, next, number 2, if aldehyde or a ketone, aldehyde you guys already might have known that aldehyde is a structure like this, and or else a ketone. This reaction conversion procedure is the same for both aldehyde and ketone. Without writing them under separate categories or separate numbers, I'll be just writing them in a common way so that you can easily remember them. Then for a ketone, CH3, COO, CH3, once you add zinc HCl, zinc with concentrated HCl will give you an alkane as the end product: CH3, CH2, CH3. Number 3, if a Grignard region is a structure like this: CH3, CH2, CH2, MgCl, this is plus and negative. If we add active H plus, finally you'll be getting the same alkane which we got before. These are the ways These are the methods which alkanes could be obtained as the products. Next, we'll move on how the way which an alkane may act as a reactant and give specific other products once reagents are added. So, number 4. Once oxygen is added to alkane, CH3 now the reagent is the alkane. Once you add oxygen, that means combustion process. This is a combustion process. You already know this. You get only carbon dioxide and water. Obviously true, right? So that's the way where we can observe alkanes acting as the reactant and giving other products by reacting with certain chemical reagents. Fifth one, again alkane. Once chlorine with sunlight or UV, you get, this is a free radical reaction, remember that. You be getting CH3 CH2 CH2 Cl. That's pretty much all you have to remember under the topic alkanes. After this reaction, after you got down with this reaction summary, please note that I'll have to come to the beginning part. For the second one, we said that zinc with concentrated HCl, this is called the Clemmensen reduction. The specific reaction name we call this is the Clemmensen reduction. And this particular scenario is called hydrogenation. It's better to know the relevant reaction process which we can easily identify without just naming by chemical symbols. And afterwards I'll be doing some questions for you so that you can revise the methodologies we used for certain reagents under alkanes. So let's begin with the first one. Better to revise them by only memorization without going through the charts or the summaries that which I gave you before. So questions. I'll be giving an alkene CH3CH CH2. Once you add hydrogen, palladium and heat it, what will be the product? That's number 1. Number 2, I'll give you some questions with regard to alkenes as well, because there onwards teaching you the next concept would be quite easier. So let us do, because this is just a practice session. Okay, once you are able to do this, better do this as quickly as possible. CH3 CH2 CH2 Br. Once you add alcoholic KOH and heat it, what will be the product? Then once an alkene is given, CH2, once you add HBr and peroxide, HBr peroxide, and the next one, question number 4, again once an alkene is given, and if you add bromine liquid, Br2 liquid, or with CCl4, carbon tetrachloride, what will be the product that you'll be getting? First, I'll just get down the answers for this and later explain how and where these reactions occurred and how these conversions could be done within less time period. So here this is easily known, I think. For this particular question, the first one, the answer is CH3, CH2, CH3. 2 hydrogens were added to this position and this position. You should balance the both sides. Then CH3, CH2, CH2, Br. In this case, once you add alcoholic KOH, we can remove one HBr. That means this Br and a hydrogen from somewhere else could be removed. Somewhere else in the sense we can create a double bond here if we remove a hydrogen from this position. That means CH3, CH2, CH and CH3, I wrote an extra CH2, that is the problem. So CH3, once you remove this Br over here and then a hydrogen from here, that means this is removed and a hydrogen not from here but from here can create a double bond. CH3CH double bond CH2, right? Next question, CH3CH double bond CH2, you given HBr and peroxide. Here it's hydrogen peroxide. There you add the hydrogen and a Br to the region given. That means you can add extra hydrogen to here and a Br to here. What we mean by this peroxide is that this Br should be added to where? To the end, not in the middle. So that means double bond cannot be broken from here. Okay, you can't add Br for other places, so you can't add Br to this particular place. Only to here the Br can be added, that means to the end portion of the reactant. The final end result is CH3, CH2 and CH2 Br. This Br is at the end, that's quite fine because of the peroxide. Fourth one, the alkene is given and you add liquid bromine. That means you can break this double bond here and add a Br to here and a Br to here, either side of the double bond only. CH3, CH3, CH, CH2. CH Br and CH2 Br. 2 Brs were added. So this is the methodology that we must be able to follow when doing organic conversions. So with immense practice, these conversions would be really simple. So moreover, we'll go to the summarization for the alkenes part. Okay, for the alkenes, we have the similar way of revising. So now that since you already know certain reactions in under alkene category, revising the concepts would be quite easier. Otherwise, once we move on further, the number of reactions that we must be able to remember is quite large. So this, whereas in alkenes, the alkene coming as a product and alkene acting as the reactant, the reactions are quite heavier than which we saw before under alkenes. So no worries about that. We'll move on with the conversions. Next topic is alkenes, but we did certain conversions and alkenes before. Don't worry about that. Even though if you got them wrong, just keep on listening. Alkenes. The chemical formula is CnH2n, and usually alkene is represented in double bond format, CH and CH2. Okay, if you are unable to write this, at least just draw the structure like this in a simple manner, and see that only 4 bonds are surrounding the carbon. So 4 bonds here, okay, 4 bonds here, 1 2 3 4, okay, here also 4 bonds. So this is the alkene structure. We can simplify and write it like this. This method is quite as the time passes, you'll get adjusted to write it like this. If you are new to organic, if you are a theory student or someone like that, then better to draw the structures initially in this manner. So if you are now we'll observe the ways alkene observed as a product. Number 1, once an alkyne is reacted with hydrogen, palladium, barium sulfate and quinoline. These two words are specific only for alkenes. Okay, alkenes. And also this whole thing is called the Lindlar reagent. Thereby you get finally an alkene, that is CH3 CH2. Afterwards, concept number 2. Once you are given an alkyl halide, that is structure like CH3 CH2 CH2Br, and once you add alcoholic KOH and heat it, final product will be a alkene, CH3 CH2. And then I'll discuss. I think the first one is obvious, right? If you are to obtain alkene from an alkyne, you need the extra reagents that you should add is barium sulfate and quinoline. If we are to convert an alkyne directly into alkane, no need of the Lindlar reagents, just hydrogen, palladium, nickel, whatever it is just fine. So keep that in mind specifically. And then the second one, we did the similar kind of a reaction, I think the same reaction before. Once you are given with the alkyl halide and once you add alcoholic KOH, and heating process removes the HBr. Okay, so this particular Br and a extra hydrogen from here creates a double bond here. That's the only scenario. Then you get a alkene. Third conversion is you have an alcohol, that is CH3CH2 CH2OH, and once you add concentrated H2SO4 at 170 degrees Celsius, or else you can add Al2O3, that is not needed. Just remembering this is sufficient enough for you to be able to do the conversions quite making it a fuss. So once you add concentrated H2SO4, again you can remove a H2O because of this heating process here. This heating process removes the water molecule. That means this OH and another hydrogen from here creates a double bond. Sorry, hydrogen removed from here will create a double bond here. This will remain, okay. Otherwise there will be no elements in the after the double bond. There are no such organic molecules exist in nature. So CH3, again CH, because one hydrogen was removed and you create a double bond. From either side OH was removed, and then CH2 is same as it is. Thereby this is a alkene. Those are the only three ways where alkene is obtained as the product. Now we will see the ways which alkene acts as a reactant and gives other different products. Once an alkene is given, once alkene, now afterwards alkene acts as the reactant. So better write alkene at first. CH3 CH2. Once you add hydrogen nickel, you get a alkane. So CH3 CH2 CH2. So CH3, okay. Second one, again alkene. Once you add KMnO4 and OH in the basic medium, you will be getting a structure like this. 2H are added to these two specific carbons either side of the double bond. Okay, so CH2, just write that. Remove the double bond which is here before, and then add the 2OH here and here. Next one, number 3, CH3 CH2, same alkene. Then you add Br2 CCl4. We did the same reaction before, that is CH3 CH2, double bond removed which is before and was existing here. Then add 2 Brs, one Br here, one Br here. Afterwards again alkene acts as the reactant, and then you add HBr, that means adding a hydrogen and a bromine to this particular structure and removing this double bond, and no need for Br to be exist at the endmost position of the structure. Only if peroxide is added to as the reagent, then that's the only method where we can give the answer. So since just only Br is given as the reagent, HBr should be at the middle, okay, not at the end. Keep that in mind, in the middle, Br at the middle. So CH3 again and CHBr, double bond is removed and you have CH3 because the extra hydrogen here is fixed to here and this double bond sorry, .com, removed. It is removed, okay, like that. Sorry. Next one, I know you'll be able to do this alone. The alkene is given, and now you are given HBr with peroxide R2O2. So here oil side, just peroxide in the sense the type of peroxide here used here is I given it as hydrogen peroxide. So CH3 CH CH CH2, here only the Br should be added. Instead of Br here, you must be able to add the hydrogen to that particular place. That means exchange the positions. Previous here, now it's CH2, the extra hydrogen was here, right? Altogether this became CH3, right? Initially it was CH2, with that particular hydrogen directly added to the last part, then so that this whole thing became a CH3 part. So here instead of CH2 and H, we should be adding a Br due to the peroxide scenario, due to the peroxide. Next, the last part, sixth one, again an alkene is given. You are asked to add dilute H2SO4. Adding dilute H2SO4 in the sense is you are adding a water molecule, right? Concentrated H2SO4 and the heating process means removing a water molecule. Now here you have to add an H2O. Adding an H2O in the sense, ignore this little thing here. Then adding H2O in the sense you should be adding remove this double bond by adding a H here and OH to here. That's quite fine, right? So that means CH3 CH OH and CH3, you just get alcohol, right? The extra hydrogen was added. This was CH2, no, you can add the CH2, like this whole thing is CH3. That means this is just the same thing which I said before, so that I could clarify you understood the concept. This is an alcohol. For that's all under alkenes. This is the summary that we have to be we should be using to revise the concepts with regard to alkenes. So afterwards it's about the alkynes and its reactions are expected to be discussed. So for today I'll be giving you some extra questions to be completed so that the new concepts that you learned here won't be forgotten easily once you practice further. So just carry on with this the homework. Okay, this is a homework for you guys. Better try this out. You can just check the summaries that I've given, and it's easily observable the methods and ways that I've explained, and you can just looking at them you can get the answers for these questions. So I forgot one thing, that is that adding dilute H2SO4 here, this is a process called hydration. That's obvious, right? Adding a molecule, that's hydration. Sorry, not dehydration, is hydration. Hydration, adding water, that's totally fine. Okay, and adding OH minus KMnO4 something I did know as the second reaction. This is called the Bayer's test. This is what we call the Bayer's test. OH minus adding a base, Bayer's test. So that's pretty much all I missed while discussing. So the homework part, I'd better write down the answers as well. Better try not to look at the answers and just try in the first hand, then look at the answers and verify your answers. So first one, it is CH3 CH Br CH2 CH2 and alcoholic KOH. Just as to remember alcoholic KOH, you have to remove an HBr. Remove an HBr. One Br from here, and the double bond should be created here, and then that means one H from here should be eliminated. I'll just write the answer here itself. CH and CH and a double bond here. Already altogether 4 bonds, okay. And then CH again, one H removed from here, the Br removed, one hydrogen removed, and CH3. CH3. Right. Second one, CH3 alcohol is given, CHOH and a CH3. You asked the reagent given is concentrated H2SO4 and you heat that. Once you heat concentrated H2SO4, I told you guys beforehand, since due to this heating process, one H2O molecule or one water molecule is released. That is this hydroxide over here and hydroxide over here, and one hydrogen from the other side is released. It could be from this side or either that side, any side you wish. So I'll take from this side, then from the initial side, then double bond created. I removed the hydrogen from here, and this also removed. Double bond CH, double bond CH, 3 bonds here, and then a CH3, CH3, CH2, 4 bonds here, 1, 4 bonds, okay, 4 bonds, okay. That's the way. If you are new, you can just identify it. Have I completed the 4 bond method in for all the carbons here, so that no hydrogen atom is missed at any point. Otherwise you lose marks. Though you know the concepts really well, you might get the chance to lose all your marks, so just by missing a simple hydrogen atom. Finally, my final question is CH3 CH CH, and there's a Br, then a CH3, then a CH3 again. You add alcoholic, I'll write alcoholic in short terms, alcoholic KOH. Again the process, think about the process. What happens here? HBr is removed, so Br removed from here, and another another H atom is removed from some. A double bond can be created in this position, thereby this hydrogen can be eliminated. That is CH3 carbon, CH3 double bond, CH, CH3. So that's pretty much all for today. Hope you guys understood these simple conversions under alkanes and alkenes. I'll be coming up with another session with regard to alkynes and others. So that's all. So have a nice day. Goodbye.